Hello everyone and welcome to the webinar. I am Nicola Migliore, the Product Development Manager for the Vcad project. Today we'll be looking at some of the new features coming to the Forge version of the Vcad Custom Visual. All of these features, especially the IoT features, leverage some of the most interesting and new features of the Autodesk Forge Viewer. We'll be having a look at some of the features that are in the current version of the Custom Visual. You may have noticed in the past month, we had some new templates available that were marked as beta. Those templates have now been switched from beta to new, and the old templates will soon be switching from current version to legacy version. We will also be looking at some new IoT features which we will be releasing in the future upcoming releases of the Vcad Custom Visual. And finally, we'd like to share with you a sneak preview of a template that we're working on for managing clash report using Navisworks models inside of Power BI directly. During the presentation, we will have two brief Q&A sections. So please, if you have any questions during the presentation, go ahead and write those questions in the question section, the question panel. My colleague Francisco will be answering some of the questions directly by text, and then I'll address some of the other questions live during the Q&A sections. With that said, I'd say we can just jump in. So let's have a look at the program. So we're going to start by looking at how we can save camera positions in our reports, then filtering based on floors, new tooltips, how we can manage large models inside of our reports, some IoT features, and as I was mentioning, the clash detection. Let's jump in with saving the camera position. So we're going to be looking at several different reports in this presentation. For starters, let's start around by moving a little this model around. So we're going to focus the camera on the back side. Then we're going to click the new save button and toggle the camera position. I'm also going to show you how you can save different positions for different instances of the custom visual. So every custom visual can be set up with a different camera position. So we're going to go ahead and set up this top-down view for the bottom left visual and go ahead and save that. Now, if we switch to a different tab of our report and switch back, we can see that the custom visuals are going to start out by loading the model inside of the actual view. And once the model has been loaded, the camera will snap back to the position that we had set up as the camera position. This, of course, will happen for both the visuals. If we want this camera position to be persistent, we, of course, need to remember to then save the report so that next time it will be loaded. So we can see on the bottom left, we have that top-down view. And over to the right, we're looking at the back of the model. OK, let's look at other things that we can save now. We have, because we're using the Forge viewer, there are several different Forge-specific settings that we can set up. These settings go from some graphical niceties to actually performance enhancers. Just for an example, we're going to change the background of our scene and maybe play around a little with the shadows. Once we're happy with the presentation of our model, we can go ahead and go to the Save button and then select the Forge settings. Now, when we save, if we switch tabs and back, we'll be able to see that not only the camera will snap back to that position that we had originally set up, like it did before, but also we can immediately see the background, the new background is being loaded in. This is very helpful because you can also save performance enhancing features. All of the settings that can be controlled through the Forge settings are available. Finally, let's have a look at hiding some objects. So we're now able to save a list of hidden objects. So if we start by hiding the wall and all the windows on its face, we'll be able to memorize the missing objects for next time we reopen the model. So now we want to go back to the Save button, check that Hid Objects tag, and switch tabs and back. This comes in very useful when you have some geometries which are hiding the view for the geometries that you actually want to focus in on your report. So think about hiding stuff like walls or ceilings and floors, for example. So again, now that what we can see, the scene already has been set up with the forge options. The camera snaps to its original position, and we have the hidden objects remain hidden, so we can see through that wall that we hid. All right, so this covers some of the new options we can save. Let's have a look at filtering our model based on floors. So we're looking at the same model as before. This is a Revit file that has been imported. And basically, if the Revit file was exported correctly, we will now have a new data set that is being generated. The data set is the Vcad levels table. This table has a list of level descriptions and the IDs of the objects, as well as an ID of the specific level. Basically, we're already able to filter or section the model based on levels before, directly inside of the Forge viewer. What we want to do is make this functionality available outside of the viewer, so from Power BI. So basically, here we have a slicer. We've bound the data to that new Vcad levels table, and we want to now make it interact with our custom visual. To do so, we go to the options, to the new section floor filter. I'm going to toggle that on. And I'm also going to show you we have another option, which is use level ID. We're going to use that later. For now, we want to go to the data bindings and find the floor filter binding. In here, we're going to drag in the description of our levels. And already, we can see that if we start interacting with the rest of our report, we're able to section the model based on the selected level. Okay, this is the easiest way to do it. We can, of course, also use that level object ID I was mentioning before. So if we remove this binding and drag in the level object ID, and then go back to the format section of our report, to the floor filter and toggle on that use level ID, which was basically going to tell Vcad that we're going to be passing in not a description, but the actual identifier of the level. And we can see the functionality remains the same. So this is great if you have a Revit model where you can control the definition of the levels and the levels have been set up properly. However, sometimes that is not the case. So we want to also be able to filter our model without using this new data set. So let's go to the data transformation. And for example, we're going to look at the Vcad properties table. In this table, we're going to have a look at the various properties we have. And we actually have a property called level, which is a property of the specific assets, which basically tells us what level each asset belongs to. So let's create a new data set based on this. So we're going to duplicate the Vcad properties table, rename it to something useful. So we're going to call it Vcad properties levels. And then we're going to apply some data transformation so that we end up with a more useful table for what we want to do. So let's start by filtering out all the properties that we're interested in. We only want to review the levels. So we're going to filter based on property name level. And already you can see here we have in our value column, we have the descriptions of the various levels that were defined in our model. Now it's very important these descriptions need to be identical to the ones defined in the model. Case is important. Now let's remove the columns we don't need and rename our value column to something more useful. Okay, and now we can go ahead and close and apply these options. Keeping in mind, we now have a table that connects the object ID to a level description. So now we're going to let Power BI reprocess the tables so we can get up and running with our new data set. Okay, so let's start by updating our custom visual. So we want to go to the options and make sure we have that level ID off because we're going to be using descriptions in this case. And for the data binding, of course, we want to pull that from our new data set, so the Vcad properties level table that we just created. Okay, and also to make sure we can connect to the outside, we're going to change our slicer we're going to make it use our new column as well. Now we can see that, again, if we make selections from outside of our custom visual, we're still able to section the model based on the selected levels. So this covers the various ways that you can sort of use levels in your reports. Let's have a look at the new tooltips. So tooltips are a standard feature of Power BI. Other visuals already have them. When you hover over certain objects, you get these little labels. And we would like to have this functionality inside of our custom visual as well. So to set it up, let's select the custom visual and head out to the Format panel. Here, under the Forge options, we want to toggle the Show Tooltip on Mouse Over On, which will basically tell Vcad that we want to display tooltips when we're hovering over certain geometries. Then in the Tooltip panel, we're going to toggle that on, and for now, we're going to leave it to default. Let's go back to the data bindings. And here is where we want to pass the data that we want to actually display in our tooltips. So let's do something easy. Let's just get some information that will describe the asset that we're looking at. So category, family symbol, and then the actual name of the asset. At this point, when we hover over the selected objects in our report, you can see that we get a new tooltip and we have all this information laid out for us. This already allows us to give more information right inside of our custom visual. But let's leverage some of Power BI's nicer features like dynamic tooltips. To do that, we're going to create a new report page and we're going to configure it to be used as a tooltip. So we want to toggle this tooltip option on. This is fundamental, otherwise we won't be able to do the rest of the configuration. Then we're going to go ahead and set the report page size to be a tooltip. This is a feature that Power BI gives you to sort of already know how much space you have to play around when creating your report. At this point, it's just standard Power BI. We're going to set up some visuals inside of this smaller report, which are going to display the information that we want to see inside of our tooltips. So in this example, we're looking at some maintenance information. We have the information of when the various objects that we're looking at have been last maintained. So let's start with dragging in the information of the name of the actual asset that we're looking at, just so we can identify it. Then we can continue with the last maintenance date. Okay, and then we actually have a reference to an external image. It's being hosted, I believe, in OneDrive in this case, but other solutions also work. Basically, we have the reference to this publicly available image, and Power BI will be rendering our image inside of the visual. So you can see we actually have a picture on site for the various diffusers that we want to be looking at. So let's complete the design of our tooltip so that we really use all the space we have available. And just as a note for the future, it can be a little finicky to actually set up the tooltip while it's already in tooltip size. Another approach could be just create the report as a full page report and then shrink it down once you have everything composed and you already have set up the visuals with the data that you want to be displaying. So for this bottom visual, what we're going to be displaying is some information about the maintenance again, which we have categorized into different levels. So based on some data transformation on our maintenance schedule, we have categorized the objects depending on the number of days to the last maintenance. And also for each category, we have determined a color, which you may have noticed previously is the color that we are applying to our actual geometries inside of the model using the coloring theme feature of Vcad. So we're just going to finish setting up the tooltip. And actually, we had a better column that is a little more descriptive. So you see here we have the various levels that we have categorized, so excellent, great, terrible, and so on. And now when we go back to our principal report, we can select our custom visual, head on over to the tooltip section, and instead of the default value here, we want to tell it to render a report page, And because we have set up that report as a tooltip, it is now available for selection. So now when we hover over our geometries, you can see we're rendering that entire report. However, of course, the data is being filtered based on the object that we are hovering over. So you can see as we move from one object to another, the data that we're showing changes. This allows us to give a completely new level of information all in our main page and in our visual. Okay, now let's have a look at how we can better manage large models using Vcad. So here we have a Navisworks model. It actually describes 2 full buildings. And I'm going to show you that when we first load in the model, it takes some time to load in. Because the model is so big, it actually has a little over 71,000 different objects. That's 71,000 different geometries that need to be rendered inside of our view. And that can be a little complex and it can take a little time. And we don't want that when we're reporting. So let's have a look at what we can change in our configuration. If we go over to the format section and then into the viewer options, we have this field called max selection count. It defaults to 90,000 and it basically tells the visual we're able to cap the number of objects that we're going to be rendering. So if we switch tab and come back again, you'll see that now the model actually loads in way faster because it's having to draw less detail and less objects. However, as you'll notice, we completely lost the second building over to the right, and we don't have control over which 30 objects will be rendered. However, this can still be a very handy feature if we're expecting our users to previously make selections on the model. So for example, in this case, we want to focus on the air terminals. It's actually only 1,000 objects, and now we're well in our 30,000 object limit. Everything loads in faster, and there's no issue because we know that the 1,000 objects will come into our level, our selection cap. Okay, let's have a look at another thing that we can do to help out with performance. First of all, we're going to reset that max selection count so we get the full idea of what we're looking at. So we'll set it back to that 90,000 default value and just switch back to another tab and over so we make sure that everything is applied correctly. Okay, now say we have this report and we have our model. For now, let's just say we're going to hide the not selected objects, and we're going to make some selections inside of our report. So we're going to start by showing the air terminals, and then we're going to add in some other objects. You'll notice every time I make a selection, in the bottom left, that loading bar appears because we're having to redraw the model at each time. This can be a little inconvenient if we expect the user to make multiple selections. So what we can do is we can actually delay the syncing of the model from the data. So now that we've toggled this, the model will not refresh until we tell it to do so. So we can make the multiple selections that we want to make. We can establish what subset of objects we want to be looking at. Maybe go a little deeper in a further level of detail. So have a look at some families that we want to be rendering. And once we're happy with the selection, we can then re-enable the syncing and the model gets drawn away. It goes super fast because of course it's only 67 geometries that it's having to draw. So we get the better performance and we're just helping to guide the user to doing the actual review of the objects in our model. These 2 features I just showed you, of course, can be used in conjunction. And again, they're especially helpful if you're making multiple selections. Okay, so now it's time for that brief Q&A section I was mentioning before. So let's have a look at if we have any questions that we can address. So we do have a couple. Okay, so hello, about the camera position. When we click on the home button on the top right corner, will it go to the save camera position? No, as of right now, that will return to the original camera position for the model. You can also, one thing I didn't show previously, is you can also reset the camera position that you'd saved. There's another toggle in that component that allows you to reset the camera position, say had you mistakenly set it up previously. Okay, then we have, okay, so is it necessary to create a new table with the single column of level name if it was already assigned in the Vcad properties traditional table? Could it be used? Yes, so could we use this table? Yes, you can use pretty much any structure you prefer. The important thing is that there is some relation between the asset object ID and the level description. So any way you want to structure that is absolutely fine. So level filter is only active in Revit, or can it be used in other BIM formats? So it is available for Revit files and IFC files. Okay, so just a second, let me pull up the other question. So what do we need to do to unhide objects? So to unhide objects you simply need to, on the bottom toolbar, where you would normally hide and unhide objects, you can do it from there, and then save again the option once you have reshown all of the objects. Okay, so I think we got through most of them. As I mentioned, Francisco will continue answering the questions while we go ahead in the presentation. We're going to get back on track. Otherwise, we're going to lose too much time here. Again, we'll have another brief Q&A section at the end of the presentation. Okay, so let's jump right back in with IoT features. So to showcase the IoT features, we set up a sample report with a very simple model and we've imported some sensor readings for some devices that we've installed in our model for 3 different sensor types, each for the various devices. So let's start by looking at the devices in the model. If we zoom in a little, you can see they're actually quite tiny compared to the rest of the model, and they can be hard to see because they're actually embedded inside of the walls. So unless we are in the X-ray view, they become pretty hard to see. However, we may not always want to be operating in X-ray view. So we'd like a way to sort of highlight these objects, even though they're kind of occluded by other geometries. To do that, we can start out with the first of the new features which we're going to show you, which is the application of markers. Before we get to that, let's have a look at the data sets. So as I mentioned, we've imported the sensor data. This table contains the information of our sensor readings from our devices. So it's fairly straightforward. We have a device name for each asset, the object ID, and then the 3 different sensor types, so CO2, humidity, and temperature. Also, we have the date on which the reading was executed, and the reading value actually that we received. Also, we have this assign room option. We're not going to need it now. We'll look at it later when we talk about heat maps. So let's go back to our report. And let's see how we can actually set up these markers. So first of all, let's go ahead and select the custom visual. And then we want to go to the format panel again and to the new marker setup. So here we're going to toggle markers on, and you can see already we have the new markers that are being designed over our model. If we zoom in a little, you can see that we're placing the markers in the geometric center of the object, so of the selected objects. This is being automatically calculated by Vcad, and there's no manual setup required if this is the desired objective. Let's see, however, how we can customize a little further these markers. So let's move along to the data bindings of our custom visual. We have a series of new fields regarding markers that we need to have a look at. So if we start out, we have this marker style, marker color, marker position, and marker GUID. So for starters, let's try applying some color to the markers. And we're going to apply color to the markers in a similar way to what we do with coloring objects based on a theme. If we have a look at our data, we've also imported a sensor types table, which simply has the description of our 3 sensor types and an assigned color for each one of them. Back to our report, and it's actually what we're showing on that table over to the left. So now we're going to drag in the color column, and you can see that now we're highlighting or actually coloring the various markers based on the color of that sensor type. So if we switch sensor types, if we focus on CO2 or humidity, you see that we're changing the color of the marker at runtime, and we simply connected that to a data coming from outside. Okay, so this is already pretty cool. Let's have a look at some other things that we can actually do with the markers. But already you can see how even showing the entirety of the model, we immediately have more information from our model. Now to set up differently the markers, we can head on over to the marker settings. Here we can actually decide a style for each one of the types of our markers that we're going to be showing. Of course, we could add new styles or we can update the ones we have. For now, let's go ahead and update the temperature. So in the marker configuration, it's very important. Here we have this type. This is a description, and it must be equivalent to the values that we have out here. Also, in this case, everything is case sensitive. That's something important to keep in mind. Then we have a couple example icons available. You will be able to load in your own icons. And let's go ahead and select a new color for our marker. So we're going to be applying this color to the icon that we've chosen. Okay, go ahead and save that. And then we can actually also set up a color for the highlighted marker, which basically will be rendered when we click on a marker to select it. Once we're happy, we can go ahead and save. Now we updated the temperature. We can save the whole thing and change tabs just to make sure we reapply the options. Okay, and finally, we actually need to tell the visual that it's no longer supposed to use that color that we're passing like we did before from the marker color. We're going to be using the marker style option. Here, we basically need to pass it in a description that maps to the styles that we've defined. So we're going to go ahead and pull in from the sensor types the actual sensor type name, so temperature, humidity, or CO2. You can see now we have the new style being applied to the markers. If we click on the markers, they go purple. So we know, and we can more easily direct the attention of someone else that is looking at a report. Marker position, we're not going to go into right now. It basically allows you to pinpoint the position of a marker with X, Y, and Z coordinates. However, it's a little out of the scope of this presentation, so we won't be talking about that. But what I do want to sort of show you is something else that we can do with markers, which is pretty exciting. So if we head on over to the format panel and to the tooltips, markers can be used to render tooltips. Again, we've set up a tooltip page. This is fairly easy in showing us the values of the sensor readings for all 3 sensor types. Now, when we hover over our markers, you'll see that we are receiving we're rendering the report, and we're filtering that data based on the object the marker is being applied to, as well as the sensor type, which is being filtered from the outside. So now we're looking at temperature, and we can see how the readings are different for the various objects. Another thing we can do is we can actually change the way we're rendering the markers. So we've been looking at it always in front. We also have an option to occlude the view, which basically means that the The markers will be hidden behind other geometries. However, in most scenarios, you'll want them always in front, but we're just giving you that level of choice. Okay, let's head on over to heat maps. So for heat maps, there'll be a lot of things to show you. Same model as before, same sensor readings, the various sensor types. We just changed a little some of the other visuals just to give you some variation. The idea is that we want to be giving the user the information of those sensor readings like we did before, but through the use of a heat map. To do that, again, we're going to look at our sensor data, so the object, the value, the type. Again, type is fundamental. The data in which we receive the data. And as I mentioned before, this is a sign room option, which is a true or false value. This will be telling us if we are supposed to render the heat map over the object that we're using or in the room containing that object. So let's go ahead and actually configure the heat map. So let's go to the format panel of the custom visual. And again, here we have some new options. If we head on down to the heat map toggle, we can toggle that on. Also show you we have some default values here. For now, we're not going to play around with these, but just to know that you can set up the default behavior of your heat map. Okay, and now going over to the data bindings. Oh, and you can see we have this new toggle already appearing, which immediately tells us that the heat maps are already been set up to at least function. So for the heat maps, we have several different fields that we want to set up. So let's start with heat map group, node, and point, which for now we're going to skip. We're going to talk about those later. Heat map type. So heat map type, we want to bind that to the actual sensor type that we're going to be rendering. So if we've gone over to our sensor types table, we can drag in the sensor type name, so that temperature, humidity, and CO2. Heat map room assign, we're going to drag in that assign room value, which again, I'll remind you is a true or false value. And we also have a toggle out here to sort of switch between the two. So I'll show you the different behaviors. For now, we're looking at assign room true. So we're going to be rendering the heat maps in the rooms that contain the objects that we've selected. Heat map position functions like the marker position. You can give it X, Y, and Z coordinates and apply the heat map that way. However, it's a little more complex. I'm not going to look at it right now. Heat map GUID is useful to avoid conflicts. It's good practice to generate a primary key for your data. So that's what you would use that field for. And then finally, we're going to drag in the actual value column. Okay, now to reapply the heat maps, again, we're going to want to switch tabs and come back over. And once the model loads, we'll see that we have the new heat maps. So we have the actual geometries of the spaces being colored inside of our model, as well as we can see on the top we have a new gradient bar, which basically shows us a color scale representing the values. We also have this heat map selector. Right now, we have a single select option for sensor types, so we're looking at one sensor type at a time. If we had multiple sensor types selected, we can actually toggle between them directly from the visual. But for now, let's just focus on one and keep it simple. If we change sensor type, we can see how the heat maps change, the gradient colors change, and the actual geometry colors change. And if we want to see the correct values, we can select one date at a time and see what the values were for the reading in that day. So how the temperatures changed over time in the various days, for example. You will have noticed when there's multiple days selected, the model goes to red. This is because the various values are being summed together. So the values for the various days. It's going out of scale. So the greatest color in our color scale is red. So it's applying red to all the geometries. Okay, let's have a look at how we can actually set up the color scale. So to do that, I'm gonna go click on the cog. Again, here we have some default values just to play around with. You can always add in new heat maps if you wish. So we have these three. You can create your own, of course, or you can go ahead and update the default heat maps. For now, let's just update the temperature. So if we have a look at the configuration, we have this property ID, property name. These are fundamental, and again, they need to be equivalent to the values of the sensor types that we're passing in, because that is how we're matching. So basically, they need to be equivalent to the value that we passed to the heat map type field. Again, case is important. Also, we have a brief description of the heat map, minimum and maximum values, which will be used in calculating the color scale, and some units of measurement. Most important, let's actually look at the colors. So here is where we manage the colors over gradient. We can, of course, add in new colors if we wish to, or we can update the colors that we have. So for now, let's just go ahead and update the colors that we already have. So we're going to keep 4 colors. We're going to completely change them just to show you how much freedom of configuration there is with the heat maps. So once we're happy with the color scale, we can go ahead and save. Then we're going to change tabs and switch back over so that everything reloads. Okay, and you can see we now have the new color scale, which has been calculated, and the actual new color over the entire geometries. Because the maximum color now is orange, the geometries are orange, which is a little less alarming than the red before. And if we switch through the various dates, we can, of course, see how the heat maps are differently rendered now based on the new colors that we've set up. So we haven't changed much, but we actually have a drastically different result. And now we're looking at the geometries, at the heat maps displayed as geometries. We actually also have a planar option, which basically projects the heat map on the level in which the space exists underneath the actual objects in the space. Depending on the scenario, this may be more useful or not. For now, we're probably just going to focus on the geometric rendering. And also here we have a tree that has been automatically generated based on the levels and the spaces to which the objects belong. So if we switch back to the geometry view, which will be a little easier to follow along with, we can actually toggle or select a level at a time. The model gets sectioned, so we focus in on the level that we're looking at. And then we actually can toggle on and off the various heat maps. So we're hiding the heat maps. Here we have an example of two heat maps, so 2 points existing in a single node and how they interact together. To make that a little more clear, we can actually switch the markers on real quick. Okay, and so you can see here at this node level of group level 1, which has been automatically created, we can see how they're interacting together in the same space. Okay, so this is sort of a good example of the easiest configuration when you're managing heat maps in a space and how the tree is automatically generated. Now, I'll show you how you can actually set up a tree with your own logic if you wish to. So if we go back to the data bindings, we're going to have a look at those values we didn't use before. So group, node, and point. In this case, the group corresponds to the level and the node corresponds to the room, at least in that tree generation. So just to set up the example, let's have a look at something simple. So we're going to assign the category of asset to the group. And then for the heat map node, we're going to use the actual asset name. So we're going to have a node for each asset. And also in the interest of keeping it simple, we're going to have a single point for each node. Okay, so now we're going to switch from assign room to true, from true to false. So we're now assigning heat maps to the geometries of the selected assets instead of the rooms. And as you can see, we're now coloring our object. And because we have a single point for each object, the heat map is homogeneous. So it's a homogeneous color being rendered. However, if we switch to, say, another date, a different object, you can see how the color is being automatically calculated based on the color scale. And regarding the tree, you can see how the tree is being generated based on the group, so category, and the various nodes, which in this case are the asset names that we dragged in before. All of these, of course, can be toggled on and off. So in this case scenario, it probably makes more sense to render the heat maps as over the rooms instead of over the objects. We've set up another example to sort of show a good use case for heat maps over objects rather than spaces. So let's head on over to the other tab. We have the installation heat maps example. Here we're looking at some some installation information for a subset of objects. We're looking at some lighting fixtures and some electrical panels. And we want to display information about the progress of installation. So we know how complete the installation of these elements is. And we want to do that through the use of heat maps. So to sort of get this running, let's have a look at the data set. We have an installation progress table, and we also have an installation levels table. Now, the installation levels table basically categorizes installation levels based on a minimum and maximum of the installation progress. It gives it a level and a color. And then we have our various intervals. Okay, this will be useful later. For now, let's have a look at the installation progress. Here, of course, we have the object ID. We have the installation progress, which is a value from 0 to 100%, which is telling us how close to completion the installation process is. And for each one of these objects, we also have, through some transformation, calculated the installation level coming from the other data set. We have generated an installation GUID just to make sure we don't have conflicts. So it's basically a primary key for each one of these rows. Assign room is always switched to false because we want to be rendering our heat maps over the objects and not over the rooms. And also heat map type is always installation because for now we're just focusing on the installation progress of these objects. Back to our report, we can actually configure the custom visual now. So we're going to toggle the heat map option on like we did before. And then in the data bindings, we're going to go a little fast here. We want to configure all those fields. So start with group, node, and point. To do that, again, we'll keep it simple. We're going to group everything by category like we did before. And then for the nodes, again, we're going to use the asset name. So we're going to have a node for each asset. That way we're able to switch on and off the heat map on an asset level. And also for the point, again, we're going to have a single point for each node. In this case, instead of the name, we're going to switch it up a little and we're going to use the object ID. However, again, we are confident that there will always be only one object ID for one asset name. So we're always keeping it 1-to-1. Heat map type, we can start pulling this information from the installation progress table. So heat map type is always installation progress. Room assign is always false because again, we want to render the heat map on the object. Let's drag in the actual installation progress level value. And finally, GUID, so we're sure that we don't have any conflicts. Okay, now everything's set up. We want to switch tabs and go back over so everything loads in again. Okay, and you can see that now we're rendering our heat maps over our objects. Everything is being colored, and we have our actual new heat map that we had previously set up. I didn't show you this, but basically, same as before, simply installation heat map. We give it a minimum of 0, maximum of 100, and then 4 colors. So, and then the colors of the various objects, as you can see, are being automatically calculated based on our color scale. For the tree, as you can see, we actually have 2 different root nodes now because we have 2 different categories. And that way we can sort of focus in one category at a time, looking at the lighting fixtures. Of course, we can switch those on and off. It's probably easier if we have a look at the electrical equipment. Let's move the model a little. Okay, and now we can switch off the various panels, solar panels, and focus in on the values of a specific solar panel. Now, some of you may be thinking this could already be done through color theming. It could. I'm going to show you how that works, and I'm also going to point out some of the differences. So here we have the same report as before, but we've created a color theme of installation, which is applying the colors to the installations. And it's based on the categories that we had set up. However, you'll see that we only have 4 colors being shown, so a finite number of colors. With the heat map example instead, we are automatically calculating the color based on the rules we've set up. So we have way more shades of color that are being applied to the various objects. So more freedom. Finally, let's have a look at the clash detection template that we're working on. This is for Navisworks models. So we're going to start in with Navisworks. Here we've opened up Navisworks. We have our model. We've loaded in our model, which of course is a collection of multiple models. And we've already set up 3 different tests. So we won't go into how you do tests in Navisworks. That's outside of the scope of this presentation, but just to see that we have 3 different tests. And actually for test 2, we've grouped all the clashes and renamed them based on the assignee. While as test 3, we haven't grouped the clashes, but we have, of course, different statuses. We have approval statuses. We have assigned them to different users and so on. If you want to share this information with our colleagues who may not have Navisworks, we're going to go through Power BI. To do that, first, let's have a look at the Navisworks options, however. So for this to work, it is important that you set up this option. So we need to go to Interface, Quick Properties, and Definitions. You may or may not have any definitions. It isn't important. The important thing is that you must have a definition for category item and property GUID, because this is how we will then do the connection between the clashes and the objects inside of our model once we're in Power BI through Vcad. So once you have this set up, you can go ahead and close everything. Let's go back to the Clash Detective. And we want to export our report. So we're going to write our report. We're going to do a combined report of all 3 of our tests, both the grouped and non-grouped ones. And we're going to go ahead and click Write Report. Save the file somewhere that we can easily access later. We're just going to give it a useful name. And once we're done saving, we can go ahead and close out Navisworks and get ready to share our information with other people. Once you open our template, you will be presented with this text box where you must give it the full path to that report that we've written in Navisworks. So we're just going to pull that XML file up, and we're going to copy both the full name and, of course, the full path of the file. Paste those right into our text box. Okay, and now once we get started, the visual will do as usual. The report, as usual, will load in Vcad's regular data sets, and will also transform and read that report that we've exported from Navisworks, generating a set of new data sets that we have access to in our report. We won't go into too much detail of those, but I'm going to show you how the report works. So everything starts out with this Clash template summary. Here we can review information of our 3 different tests. And we have some indicators, so number of clashes or clashes for a different status. What's very important here also, we have this tags with errors. We want it to be blank. Blank means we have no errors. It's great. Otherwise, we may have to have a look at the data transformations and make sure that anything didn't go wrong during the initial import of data. We also have some other visuals sort of comparing the various tests. So we can see test 1 had a bunch of clashes in new status, and further revisions of the tests, things were better. Let's head on over to the Clash Detective report page. This is a recreation of the Clash Detective functionality inside of Navisworks. So again, we have our 3 tests here available. We can select a single test, and we can see which objects of our model were involved in the clash. We also apply a marker for each and every clash that was detected. Also, The clashes here, we have a list of our clashes. They're grouped as they were grouped in Navisworks. So if you remember, test 3 was grouped. And if we focus in on a specific group, we can see one of Jack's clashes. These are the 2 objects involved. That is where the clash happened. And we can see a little more information about the objects that were involved and the files that were involved. Also, we set up a tooltip with these markers to give us information about the clash and every comment that was ever made based on that clash as well. If we head on over to the test overview page, this page is sort of focused on getting an idea of the whole test. So we can select a single test, and we can see that in this case, most of the clashes are either been approved or resolved, which is great. If we want to go deeper, we can focus in on the work of one assignee. So we're going to look at Emma's work now, and we can see the 3 tests that were assigned to her. Again, we can click a single test and review the objects that were involved in this specific clash, as well as have information both of the name, the object type, or the comments for that clash. Finally, as a theme, we can either color the objects differently, or we can color them based on the status of the clash. However, keep in mind that objects can be involved in multiple clashes, and the various clashes can have different statuses. So in this case, everything is yellow, it's fine. In this other case, the objects are involved in 2 different clashes. So one is yellow, one is green. So that's just something to keep in mind if you're applying a status theme. Finally, Smart Tag Overview is meant to help you easily see if there's any problems with the Smart Tag extraction, which are basically those script properties we set up in Navisworks. If we focus in on a specific test, we can see that has tag errors. We don't have a true option to select from, which is great. It means everything went fine. And for each clash, we have those quick properties that we set up previously. So we have the item GeoID and we have the item name that we were looking at before. Again, item GeoID is the one that is fundamental. Okay, this covers a quick sneak peek at what we're working on with this new template for managing clashes in Navisworks, and it's really cool because you can share this information more easily. Time for another brief Q&A section before we sort of close for today. So let me pull up the questions. So can we use the X-ray feature in the clash detection dashboard? Yes, you can absolutely use the X-ray feature. I think that during the video, just for clarity, I didn't actually use the X-ray version, but it's absolutely available to you if you want to. The rest of the visual functions normally, so everything you're usually doing, you can still do. As you saw, you can do the tooltips, level filtering would be available as well, and things like that, provided the file supports it. So I guess level filtering not, because it's a Navisworks file. So in the future, will there be a version for the analysis of clash from BIM 360? Yes, that is a feature that we are definitely looking into. As of right now, we're managing the extraction of clashes directly from Navisworks, but it's definitely something that we're looking into and exploring right now. Is it possible to configure the marker icon? Yes. During the presentation, I showed you just using the default icons that will be available when you first use the new version of the custom visual. However, you will be able to load in your own icons that can give you even more meaning directly inside of the report without even having to color them, for example. Let's see. Are these features only available if we use Forge? What are the limitations using the standard IFC file upload of Vcad? Yes, so all the features I showed you today are only available for the Forge version of the custom visual. They're features that we're thinking about implementing in the Open Viewer in the future as well. However, most of the features we showed you today are leveraging Forge-specific assets and tools and features. So it will take a longer time to figure out a way to bring those to the open viewer if we manage to bring everything. But so as of right now, only Forge. It's something that we're thinking about for the future. Okay. So I think this covers it. Again, there's another couple questions we won't have time to get into right now. We'll definitely get back to you either on by email or on social media, things like that. Before we leave, we'd like to send out a quick poll to get some feedback from you about which features that we talked about today you would like us to further look into in the future. So basically, give us an idea. We'll take your feedback and we'll try to expand these arguments in the future, either through articles or making more videos, or perhaps if there's interest, maybe another webinar more focused in on one or two features. So I'll just give you a couple moments to go ahead and vote. Please do vote. That is super helpful for us. The ones of you that have been with us for some time know that we're very user feedback oriented. We try and take all the feedback we can and really treasure it and let it guide us in the future developments of this tool that we're creating. Okay, so the results are coming in right now. It's looking like a pretty close battle. I think we're going to close this really soon, and I'll share the results with all of you so you can see them. Okay, let's go ahead and end the vote. And everyone should be seeing the results right now. So it looks like it's a two-way tie on how to manage large models and IoT features and report setup. So definitely we'll be exploring these two further, as I said, either through some articles, videos, or if there is some further good feedback from you guys, maybe we do another webinar focusing in on one or two of these. And of course, we'll also have a look at the other ones for the folks who voted for the other options. Okay, so I think with this, we're gonna try and close this out. Leave you guys with 1 minute to spare, so don't anyone say we weren't punctual. Absolutely, thank you guys, everyone, for joining and for participating in this webinar. Really excited about this. As I mentioned, we'll try and get back to everyone who had questions that we didn't have the possibility to answer through either email or social media. And if in the following days you do have other questions, absolutely reach out to us. Most of you know it. Francisco is always on point and happy to help. All right, so thank you, everyone. Thank you for joining us, and have a nice rest of your day, evening, night, morning, whichever you're having. Goodbye.